Okay. Discrete time Fourier transform, that is, this is the short form, DTFT. And what we have discussed so far is the continuous time Fourier transform. That is the Fourier transform of continuous time aperiodic signals. So today we are going to discuss Fourier transform of discrete time aperiodic signal. So let me recap the that formulas. That if xt is the signal, then x of j omega, this is notation we have used for continuous time Fourier transform. Okay, and this is defined as integral minus infinity to infinity xt e to the power minus j omega t dt. When we derived this formula, we started with a continuous time periodic signal, and then we increase the period, and in the limiting case it tends to an aperiodic signal. That's how we derived the Fourier transform of continuous time signal. Using the same approach, we can derive for Fourier transform of discrete time signal. That means any aperiodic signal, take it as a limiting case of a periodic signal. Then in the limiting case, you will get discrete time Fourier transform. I'm not going to prove again. I'm not going to prove it. How in the limiting case it approaches that function. So I'm just writing that formula, that equation. It is here. Only different. The expression is also similar. The only difference is that here t is a continuous variable, and when we talk about discrete time signals xn, it is a function of a discrete variable. So this is summation xn e to the power minus j omega n. Okay, this is the Fourier transform of discrete time signal, and I am writing it as, I'll explain why I'm writing it as a function of e to the power j omega. So this one, it is similar to this. Only difference is that it is summation instead of integration. Okay, this is called the discrete time Fourier transform of signal xn. Okay, now why am I writing it as a function of e to the power j omega instead of function of omega? What is the reason for writing this x of j omega?
Formula is similar to Laplace transform.
It is somehow related to Laplace transform, because Laplace transform is integral minus infinity to infinity xt to the power minus st dt, isn't it? So when you put s equals to j omega, that here s is a complex variable, sigma is the real part, and j omega is the imaginary part. When the real part of that function is 0, then that is the Fourier transform. So we can say that the Fourier transform is a special case of Laplace transform. Anyway, we will discuss those properties later. So here, is it similar to some other transform that you have already studied? This summation?
Z transform.
Z transform. How to define Z transform of a signal? It is x of z is summation minus over n xn what? Z raised to minus n, isn't it? This must be the...
Yes.
What is z here? Okay, so this is the Z transform. What is the variable Z? Is it a complex variable? What is Z in Z transform? It is a complex variable. Okay, it is a function of a variable Z. Z is a complex variable. And if we write it in the polar form, let's say mod Z is R and phase angle of Z is omega. Then can you tell me, is there any relation between these two?
See.
What is that? X e to the power j omega is xz at when? Z is
R1.
R is 1. So here, only thing you have to remember now is why we are using x e to the power j omega, because this is a special case of Laplace Z transform. When z is equal to e to the power j omega, then it is discrete time Fourier transform. That's why we use x e to the power j omega. Now you should remember the difference between, if you consider a continuous time signal xt, its Fourier transform is represented as x of j omega, and discrete time signal x e to the power j omega. Okay, this is continuous time Fourier transform if you consider continuous time signal xt, and if you consider discrete time signal xn, it is discrete time Fourier transform. Okay, now what about the inverse Fourier transform, inverse discrete time Fourier transform? This is the discrete time Fourier transform, finding the Fourier transform x e to the power j omega from xn. Now if you are given xn x e to the power j omega, then how to find xn? Okay, before explaining that property, let us see this some properties of this discrete time Fourier transform. Can you tell me, is there any difference between this and discrete time Fourier transform? Sorry, continuous time Fourier transform. I can write that expression here, xt e to the power minus j omega t dt. Okay, here it is summation because it is a discrete variable, and here it is a continuous variable. Can you tell me, is there any periodicity here? We are writing it as a function of x e to the power j omega. Is it a periodic function in omega?
Yes, sir.
What is the period?
2 pi.
Omega plus 2 pi. That is that summation n is minus infinity to infinity xn e to the power minus j omega plus 2 pi. A discrete time complex exponential signal. This is same as e to the power j omega plus 2 pi n, isn't it? Because n is an integer. 2 pi n is always 1. This is a property of discrete time complex exponential. But this is not the case for continuous time complex exponential. There, if you take any value of omega, there you will get distinct complex exponentials. But here, there is a periodicity in omega. Okay. So here, this one. So that is a difference between continuous time Fourier transform and discrete time Fourier transform. There is no periodicity in x of j omega of continuous time signals, but for a discrete time signal x e to the power j omega, this is 2 pi periodic in omega. It is a function of a 2 pi periodic function of omega. So if it is 2 pi periodic, we can write the inverse Fourier transform. Okay, first let me write the inverse Fourier transform for a continuous time signal. If xt Fourier transform is x j omega, its inverse Fourier transform, this is the inverse Fourier integral of continuous time signal. That is xt is equal to 1 upon 2 pi integral minus infinity to infinity x j omega e to the power j omega t d omega. This is we have already seen for continuous time signal. Now for discrete time signal also it is similar expression. Xn is 1 upon 2 pi x e to the power j omega e to the power j omega n d omega. Expression is same, but only one difference. What is the difference?
2 pi
Integration
period.
over a
It
period.
is integration over a period 2 pi because it is a 2 pi periodic function in omega. So that is the only difference. And the condition for existence of discrete time Fourier transform, it is also similar. Like in the case of continuous time signal, the signal should be absolutely integrable. Here, if for a discrete time signal, the signal should be absolutely summable. So that condition is also similar. Okay. This is DTFT. This is called DTFT, and this is inverse discrete time Fourier transform.
Sir, why is it not a summation inverse time
But
Fourier
this is a
transform?
function of a continuous variable omega. Here it is n is discrete. What is this variable omega? It is a continuous variable omega. It is not discrete.
Yes, sir.
So that's why it is integration. Only in the time domain it is discrete, but in the Fourier domain it is not discrete. It is function of omega. Okay.
Okay, sir.